I'd like to go into details on how we can advise students and educators when educating neurodiverse learners in mathematics. The Exeter Spectrum Project is an education incubator project exploring how we can best support autistic students at the University of Exeter. It's intended to complement the existing structures and mechanisms and activities already undertaken primarily by the accessibility team and their mentors. This project is co-led with Professor Barry Cooper and spanned just over 18 months. One of the main concerns in designing the project is that few staff are aware either of what the university currently does for autistic students or how they themselves can adapt their practices to becoming more inclusive, particularly in respect of autistic students. We therefore determined that a key strand of the project would be to convene a group of Autism Champions from as many departments and campuses as possible, so that we could discuss the challenges and opportunities associated with supporting autistic students, spread awareness of the university's existing initiatives, and could help each other and services to host its own conversation about autism. And we noticed during the Autism Champion meetings that there is significant diversity within the group of Autism Champions themselves, from those who have direct experience personally and or professionally with autism, to those staff who wanted to know more so that they can do a better job as a personal tutor or lecturer. Very few champions knew initially of the existing provision for autistic students. So we worked closely, not just with the university members, but also with the National Autistic Society, so that they can help us evaluate current practices and coordinate the project as a whole. We also had a steering group who can help us oversee the outputs of the project as well as the finances. We planned to have a 2-day summer school for prospective students. Due to the pandemic, that 2-day summer school did not take place. We also planned to have a 1-day conference on autism in higher education. Again, because of the pandemic, it didn't happen last summer. However, this summer, and last Thursday, in fact, we hosted an online event on autism in higher education. So we had a few meetings and we learned a lot from each other and from the National Autistic Society. And given the diverse nature of autism spectrum conditions and the individual needs of autistic students, a very real question for the group is to what extent general advice can be distilled and given regarding autism. There were some very interesting and practical ideas that emerged from these meetings, particularly from our discussion with the experts from the National Autistic Society. When things moved online, we then started to discuss and share ideas and views about how learning online helped or affected autistic students in different ways. We had several reflections from these meetings, and some ideas that came were allowing students to create learning statements or profiles when they first start their university course. So they can detail in this statement what learning techniques works for them the best and how they prefer to communicate not only with their peers, but also with their lecturers. This particular technique seemed to be precisely the sort of initiative that could normalize discussion around learning preferences and individuality and would promote diversity and the richness that results. Another example was presenting information via different modes depending on the preferences of that student. Some autistic students struggle to retain additional spoken guidance and would benefit from it being written down, particularly if it's not recorded beforehand and available to them. The importance of recording as a tool for promoting inclusivity was emphasized as part of these discussions. Another example was ensuring that clarifying questions are answered in communication to the whole class, such as using a virtual learning environment, which can help to ensure transparency and parity of information available, and can ensure that students who struggle with personal communication of this nature don't miss out on responses that they would find valuable. Now looking at teaching mathematics at higher education, the conversations that we have and continuously have in terms of what can we do while designing a course and delivering the course, how can we make it so that it's suitable and helpful for neurodiverse students? And so these conversations need to remain equally balanced and focused on opportunities that arise from neurodiversity and methods to promote inclusive planning, teaching, learning, and assessing. And we're going to touch upon some of these today. One example is making expectations clear. Not only making it clear to students what's expected from the lecturer, but also making it clear to students what the lecturer expects from them. Having transparency from day zero is very important for neurodiverse students to plan their time and to collect their thoughts about the course and what it entails way beforehand before it starts. And it leads to another important theme, that approaches that we undertake for this to supporting neurodiverse students are likely to benefit many other students, and that inclusivity essentially benefits everyone. Proactively addressing the concerns, say, that neurodiverse students have about what to expect from university are very likely to improve the expectations of many other students who don't have a diagnosis. And so storytelling is important, an important part of valuing diversity. One example in mathematics, as well as many other STEM subjects, having clear notation is key. When we come to introduce a statement, whether it's a definition or a theorem or a corollary or a proposition or a lemma, before anything, it's important to communicate the difference between these types of statements. And if we're going to introduce notation and symbols within that statement, it's important to explain the abbreviations and notations used beforehand. This causes much less confusion when introducing the statement or its proof or any application that comes from that statement. Also, having a separate list is useful as a reference point. Looking at a whole module or even half a module, having a page or two list of things that the student can refer to during the duration of the course is key. And having such a list acts as a reference point for the neurodiverse student who may experience issues with working memory and need more frequently check the meaning of each of the variables or symbols used within that topic. Also, having full notes available beforehand can also be helpful, whether it's to plan their time or even just to read beforehand before that topic is taught by the lecturer. And it also provides the opportunity for the student to revise the required topics. The student will be more fully prepared that way. It's also further recommended that inbuilt and frequent recaps will enable the student to fully assimilate the material. And such differences can have a huge impact on the student's experience while learning that course, particularly with mathematics, because the topics are very synoptic. So in order to understand multivariable calculus, the student should first understand calculus at an intermediate level. Resource design is also very important when considering neurodiverse students. Many students find it much easier to have a visual interpretation of the theorems and statements given. So one popular technique is to use tree diagrams. Instead of having a list of dependencies, having it graphically, as for an example, an ontology or a flowchart, could help them collect the links between the various components of that topic. For example, demonstrating the prerequisite of a theorem and then demonstrating where that theorem is going to be used later on. One quote was, "Clear and unambiguous lectures are supportive for neurodiverse students who prefer clarity, predictability, logical explanations, and tangible expectations." And just ticking those while designing lecture materials can make it very much easier for the student during their learning journey. And sometimes when they get confused or uncomfortable in any way while learning a new topic, it can be a demotivator and just disencouraging them to move further with the topic. Another example is using colors. For example, in mathematics, we occasionally have using equations that depend on previous equations or a single notation that has two different meanings. It could be that alpha means something in one place, but it means something else in a different place. And so using colors is one way to distinguish between those two different meanings. Another example is having substitutions. In mathematics, we use a lot of substitutions. A simple example would be that if 3 is less than 4 and 4 is less than 5, then 3 is less than 5. Demonstrating the inequality between the 3 and the 5 using the same color just makes it much easier for the student to grasp the content that's trying to be conveyed to them. Also using behaviors and patterns and techniques followed out throughout the module. If, for example, the educator decides to use colors to represent substitutions or theorem dependencies, it's important to use that same pattern coloring throughout the whole module. If not, it could lead to confusion. If we're using it in one place, but not in the next chapter, the student may realize that maybe this is not a substitution, or maybe this is not a connection from one theorem to another. So consistency is key. Also, making it clear of the layout of the resources. For example, the positioning of diagrams in lecture notes can make a big difference. If mentioning, say, a figure and then placing that figure 3 pages or even just simply the bottom of the next page could cause confusion. And so placing them in certain locations on the lecture notes could just make the notes more reader friendly. We often talk about coursework versus exams. When do we use coursework? When do we use exams? And how do we design them? When answering these questions, it's very important to have neurodiverse students in mind. In many cases, the way we design exam questions is discriminating against some students. For example, a well-constructed piece of investigative coursework may allow the neurodiverse student to develop their own ideas outside of the constraints of the examination and demonstrate their underlying mathematical ability. However, its credit-bearing tariff means that within the full picture, it's a minimal contribution. In exams, if we use, whether it's a paper exam or an online exam, in mathematics, sometimes we require an accuracy of the answer submitted. However, these forms of assessments are likely to disadvantage neurodiverse students in transferring from one medium to another, such as from the calculator to the test paper, or from the calculator to a screen. A dyslexic or dyspraxic student may struggle to copy correctly or even reverse some of the digits. And so when designing questions and designing the technique that the student needs to input their answer, we need to take into account whether these questions and modes of input are disadvantaging certain students. Another example, for ADHD students, a comment in the literature mentioned that because focusing on a selected task will be hard, for example, needing to use a specific formula or an equation, they may tend to make so-called careless mistakes. And so it's really important that when we design how we want the student to communicate their understanding of a topic, then the question, the assessment as a whole needs to reflect that. There's also another quote on this slide about asking students to state a particular definition or a particular theorem, and then ask them to prove it or to apply it. In some cases, simply asking the student to state a theorem and awarding them the marks is not a clear indicator that they understood it. For many neurodiverse students, for them, reflecting their understanding of that theorem is not through stating it, it's through applying it. It's through implementing it in a particular example. So that's, thank you very much for listening to my talk. And these are the main references used for today's presentation.